My name is Franz. I'm here principal scientist and director of the machine translation research team here at Google. And so what I want to talk about is statistical machine translation, just the progress that has been made in the last years and in general in the field, but also here at Google. So why is Google doing machine translation? I guess you have seen this slide probably today 5 times in 5 different talks. So Google's mission is to organize all the world's information, make it universally accessible and useful. And with making the book corpora available to everyone, you can search that, and the web is there. And Google is doing search and all those things. But the language barrier is still a barrier which is very significant for many, many people. If you speak English, you can access a lot of information, but many people on this planet don't speak English. And so if you only speak Arabic, you can only get access to 1% of the information. Even if you find all the books in English and can find them, but you cannot really get access to the information. And therefore, machine translation is really core, we believe, to that in order to really provide access and make it useful to anyone out there. So I want to talk about some topics of the trends there. So one is that machine translation significantly improved in quality in the recent years. So just to give an example, here's an Italian text. I'm not sure how many know Italian, but it doesn't matter so much. So here is the machine translation output and a human translation output. And normally people would expect machine translation, I know it makes mistakes, it's always funny and it's hard to understand and it's confusing and all that. And so here, if you read through those 2 different texts, try to find out which one has been produced by a professional human translator and which one has been produced by the machine. And I guess it's quite challenging, but some people actually figured it out. But it's quite hard, right? It's both texts sound fluent, both texts have minor mistakes. But you can get a lot of information out of machine translation. That's for Italian to English. Italian and English are relatively similar languages, so it's easier to do that. So if you look at the same text and look at the translation from Hindi to English, then you see many more mistakes. That there is this lunar probe, prikramam, or some word which got transliterated, which the system didn't know. But you can still kind of get a rough idea of what this text is about and can get access to information in there. It's just not as fluent as it works for Italian. Okay, so so now I want to go through some of those things which caused a significant step forward in quality in machine translation, that we are now able to produce that kind of quality in machine translation. And so one key thing is that now people are doing statistical machine translation. That's what we are doing at Google, and what now a large part of the research community that's working on machine translation is doing. So the basic challenge is natural languages are very ambiguous. There are a lot of different ways to express things. There are nuances in the meanings of words. Meanings depend on the context. And so to produce a translation, you have to make many decisions. You have to make decisions under uncertainty. And what should we do there? Well, we should try to make optimal decisions. And that's what statistical decision theory is about. And so the statistical approach provides there all these advantages that we can combine all the fuzzy and errorful knowledge sources that we're having. And the key is that we then learn from data. So we learn from large amounts of parallel documents. And at Google, we have access to lots of different corpora and can mine those for translations. And the more data we provide there, the better the translation quality is. I'll show later some slides. And then we measure, we are very metrics driven there. Then we measure the success by performance on unseen test data. And when we implement something, we see if it improves. And if it improves, we keep it in the system. And if it doesn't, we don't do that. So it's now, in the old days, machine translation was built in a very different process than what's done here now. So I don't want to go into the details. There's not much time in the details of how the statistical machine translation model that we are using is really working. Just a rough overview. So in the end, it's a linear model that we have all kinds of different knowledge sources. Each knowledge source has a weight associated with it. We combine all those and we try to basically find the sentence in the target language, which is according to those knowledge sources, the best one. And basically a lot of the work in improving the quality of the system is to provide extra new knowledge sources. And the key the key element in the translation model is what we call the phrase table, the translation dictionary. And so as a starting point, what we get is just we have large amounts of parallel text, so large amounts of corpora which are in Chinese and English. And from that, we have to infer now how Chinese words translate to English words. And the approach to do that is basically to analyze co-occurrences between those, and then to bootstrap from that. If you have some knowledge about some co-occurrences, you can iterate a few times over it and get better and better estimates over that. And the infrastructure, if you do that over gigantic amounts of data, that's very natural to do that. It's just MapReduce. And then you run that on a few hundred or a few thousand machines, and you basically learn then how all those words in all those languages that we are working on relate to all the other words. And so as part of that process, we basically know then not only what we learn then which word corresponds to which word, and from that we extract then which phrases correspond to which phrases. This is then a very simple process where just we memorize basically all the different phrases that have ever occurred there in those corpora, and associate with them some numbers, quality metrics that tell us how good is that phrase, and depending on various other pieces of information in which context it fits well and which doesn't. But in the end, it's basically a very, very large table which is stored and which then describes how to translate from Chinese to English, for example. So a phrase which has been seen, for example, many, many times, that's a good phrase. Or a phrase that has been seen in many different types of text on many different web pages or so, that's, for example, a good phrase. But there would be other metrics, like if the phrases before and afterwards are aligning well, then the phrase which is in the middle is probably also a good phrase. Right. Poetry is one of those things where if you send it into the system, you get new kind of poetry out. So it's it adds to it in interesting ways. So that's with respect to the model, and there's a lot more to be said about the way those models work. But I think the essence is it's all data driven from parallel corpora. And it's in the end, it's relatively simple models. And the key is there that you do it over gigantic amounts of training data. Another key which was introduced there is that we now use in the field in general automatic evaluation metrics. So in the old days, if you try to implement an improvement in a machine translation system, you build something in, and then you had to ask human raters in order to know whether there was a good translation or not. So now what we are using is automatic metrics where we compare the translation that's produced by the machine translation system to human reference translations, also on large amounts of text. And then we basically say if it's very similar, then it's a good translation. And if it's very different, it's a bad translation. And the key is this metric is not perfect, but it's good enough in order to drive progress in the field. So we have a very fast development cycle then. If I have an idea, I want to implement that, I can verify it and get a translation quality very quickly. It's very easy to compare and assess results. If one research team is presenting some numbers, others can compare to that. Very cheap evaluation. And another key is it allows then direct optimization for that. Once you have a metric which you can automatically compute, you can also tune your system directly to basically optimize directly with respect to translation quality. So the web has actually large amounts of parallel texts, for example. So if you go to the United Nations website, they have all their resolutions and all the meeting notes and everything is available in all the 6 languages. Right. It's much smaller than the whole web. But the whole web is so gigantic that the amount of parallel data still is rather significant. And then United Nations, you get, for example, there about 200-300 million words for each of those languages, and then parallel. And 200-300 million words, so for those languages, that's a pretty significant corpus. And I'll show later some numbers which show basically how much data you need in order to build a decent system. It's all then, I know, a special kind of language, United Nations kind of language, which might not be the best thing if you want to translate poetry. But still, it's then the key then there is it's good enough in order to get understand what the text is about. So here now to more parallel data is better data. So what I show here is a bunch of numbers which says if you have 1 million words of parallel text or 10 million parallel words of text for different languages, Portuguese, English, French, English, what's the improvement in quality? And the metric that's shown here is this blue metric where larger numbers are better. And so it's a metric which is from 0 to 1. And about 0.2 is a level where then the translation quality becomes reasonable, that then we'd be willing to basically give that in front of our users and say, oh, that's good. But language like the Hindi language also, that's then above this level, but quality is not as good as we want it to be. But if you see then with 1 million words, just very few languages, just Portuguese is above this level. But then with 10 million words, many more, 2 more languages here jump over it. But then if you just go another factor of 10 and add more data, then all languages are above this 0.2 line. Or then if you go to 1 billion words, then even more, all of them reach now 25%. And so you see, the curve seems to slightly go down in slope a little bit. But it's still, if you add more data, it's always gives you better translation quality. So that's one thing. Why is Portuguese so good? Well, Portuguese is a language which is rather similar to English in the sense of it has a very similar sentence structure. And the Romans invaded Britain, and therefore, I guess the English language deviated from the Germanic roots and went more similar to French and Italian, and at least with respect to what matters for our statistical translation model. So those are just very similar ones. The other ones, like Finnish, for example, is very challenging because it's such a rich morphology, especially for small amounts of training data. Then this is really challenging because many words we just have never seen. But it's interesting then that Finnish also has a steeper slope. That if you have a lot of training data, then actually it's good that you have so much information in a word, where in Finnish it's all the gender and what case in the sentence is having. It's all embedded in a word, and that is actually helping then a lot if you have large amounts of data. But to some extent, it's also we have to be a little bit careful. Those numbers are all actually on the same corpus. They are as comparable as you can get them across different languages, but there is still a problem that then the data has been produced by different human translators, right? And then it might also be some of it here is that the Portuguese translator was more consistent than the French one, for example, and therefore the gap is there. But still, it roughly gives an indication about also the quality of our online system. Our Portuguese system is one of our best ones. So another graph here, which goes to the up and to the right, is basically improvement over time. So this now includes basically data and algorithm improvements, and those are some of the languages which we launched recently, so Hindi, Thai, and Hungarian. And there you really see significant improvements over time that then, so in there you see we find more data for those smaller languages, and it's quite challenging for some of those languages to find data. For Chinese, large amounts of data are out there. It's one of the United Nations official languages and so on. But for Hindi or Thai, there is not so much data. So our algorithm has to be searched deeper in the web in order to find those texts. But as you can see, there is very nice progress over time for many of those smaller languages for which so far it was very hard to find machine translation systems out there. So another curve here shows the same thing for the language model, where basically, so here now the amounts of training data for the language model. The language model is basically the model for which we judge, with which we judge the well-formedness of the target sentence. And it's just an n-gram language model where we count n-gram compute probabilities based on how often something has been seen. And as you see here, so there are some details in that graph where I don't want to go into, but the more training data, whenever you double the amount of training data, for example, for the very best amount of data that we have here, it's news data, we get 0.6% absolute gain in that blue score metric. So, and because at Google we can double there quite often, we get high scores then there in the end. So one challenge then obviously when you have those very large amounts of data is that those models are becoming very, very big. So the phrase table or the language model, that's a very large table, but it has hundreds of gigabytes of data that we want to have random access at translation time. So one challenge there is we cannot just fit that on one big computer, or if we would put it on one big computer, that computer would be very, very expensive. But what we need is to have then many translation machines which perform the translation, accessing one shared pool of that data. So what we then, a large amount of work went into building a distributed language model, or the same thing, then distributed translation model architecture, which allows then very efficient access, random access at that time when we need it to the data. So a lot of work actually in building the machine translation system to produce high quality, exploiting those large amounts of data, is actually core systems work to make sure that we have very few millisecond round trips whenever we need a language model probability to get that back and to batch those up in the right way and so on. So another graph here is, and also a big reason for the progress in the field of machine translation is that there's a huge excitement right now in the research community. Many people are working on in the natural language processing field. There were very few papers a few years ago, here in '98, which discussed that, and now there's really a few hundred papers every year that discuss statistical machine translation. A lot of interest there. And one reason is it's relatively straightforward for a very small team to build a decent machine translation system by taking off-the-shelf resources and their open source software, their parallel corpora which are available, standard evaluation sets, and to build a system with which you then can write a paper and do interesting research with. That was not possible 10 years ago, where the rule-based systems, there was a very complicated system, just proprietary access at some companies. And so it was just very hard to do their relevant research, but now it's really out there, and a PhD student can, on his own, do a lot of interesting things. So one challenge then, obviously, is if you want to use very large amounts of data, how can you do that? That's a challenge if you're a small research group. So at Google, one thing that we have done there is to provide the Google N-grams, so which is a set of 5 grams counted on 1 trillion words on English web, and made that available through LDC. So if anyone is interested in that, you can contact their LDC. It's a nominal fee, just and it's, I think, on 5 DVDs, all that data. And what we are working on right now, and it should be available hopefully very soon from LDC also, is a corresponding data set with 10 languages, 10 European languages, so all those languages that are shown here, and also counted on 1 trillion words overall, but each of them counted on roughly 100 billion words. And so with that kind of resource, then people can build language models and can build machine translation systems for all those languages. So with that, also we hope that there's more research happening that builds machine translation systems to translate from English into other languages. So a lot of funding, and especially government funding, US government funding that goes into machine translation, always focuses on, for example, Arabic into English or Chinese into English. For us, it's actually more interesting to go from English into other languages. Our usage is much higher from English into Arabic or English into Chinese than the other way around, because all the information is available in English, and it's all about providing access to information. Okay, so the next step is now we can build machine translation systems for many more languages. So here is a history of Google Translate. By the way, who is a user of Google Translate? Who has used Google Translate ever? Not every hand goes up. So here the Google Translate got started in 2001, and then we used off-the-shelf third-party product rule-based machine translation system. And then at some point we started a research project here. Can we advance the state of the art in machine translation by exploiting our computational resources, the data that we're having, and the computational infrastructure that we're having to really make machine translation better, to provide it for many more languages. And then in 2006, we started basically to release 3 languages, which were then our own statistical machine translation engine, Chinese, Arabic, and Russian. And then since then, in 2007, October 2007, we replaced all of our rule-based system with that statistical engine, and then moved on. For every quarter, we added 5 to 10 languages. And now at this point, the most recent addition was Farsi. We have 42 different languages from which you can translate from any of those languages to any other language. And now it's really possible also to look at languages where a few years ago it was just unthinkable that anyone would build a machine translation system. Even if you would have asked me a few years ago if you can build a statistical machine translation system for Yiddish, I would have said, no, we won't be able to find the data, and so it's not going to be in the foreseeable future. But actually what we have now is a research prototype for a Yiddish translation system. So Yiddish is a Germanic language written in Hebrew script, a very small number of speakers. It's one of those endangered languages. And there's just very little modern text written in Yiddish. But really, the question is, can we build with those techniques of statistical machine translation a system? And normally you would say statistical machine translation is not really ideal for this challenge, because where is the data, right? You need large amounts of data in order to feed that into the system. And actually we also, there is not so much data out there. We found a few 100,000 words. But then there's really also a lot of interesting algorithmic work in order to exploit similar languages in order to improve a language like Yiddish. So here so there are dictionaries available, so you can add dictionaries and the translation quality nicely improves. Yiddish has specific morphology issues which you can deal with. But then German, Hebrew, and Polish are very similar languages. So all the knowledge that we have learned from those other languages, for which we have really large amounts of training data, you can put them together and put into the system. And then it seems that a lot of text also is misspelled that we found. So spelling correction is helping there also a lot. So overall, we get close to that level where we said machine translation quality is reasonable. So here you see a translation of our very current version of the system, which is actually even better than those 19.5% here of the same text that you have seen before. And it's, I don't know, you have some struggle to understand some of those things, but still it gives a rough idea about what's happening there. And if you know some German, there are some funny kind of, if you sound it out, you know what it means, even if it doesn't seem to make direct sense. So we translated that into Yiddish. So basically, therefore, we have the same text available in all those different languages. So that's part of our test data, which we then have the same text in 60 or so different languages. Right, well, it's basically a Yiddish translator produced the text for us. Okay, so another trend is machine translation everywhere. So I might be biased, but that's obviously one of the goals that I would want to see. So one of the things is just for many years, that's what Google is providing since 2001, this text translation interface where you can go there, paste the text in, translate it into some other language. And now we have that basically for those 42 languages from any to any other one. Or you can paste in a URL and then have the web page translated to you. But then what do you do if you don't know what you want to translate, right? You want to know some information and you don't care about that you first have to find it. So one thing that we have launched recently is cross-language search, where you basically can type in a query and then you can search a different language. So for example, here digital SLR camera, and you type the query in English and you search the Japanese web. And then what you get is basically search results in Japanese. So the query gets translated into Japanese, search results in Japanese, and then translated into English. And if you click on the English search results, you will go to a translation of that page and can basically find out information as if that all were written in English. Or if you know some Japanese, you can click on the Japanese result and go through there. And so another one, for example, the caption translation, which actually was mentioned already before, that for all those videos which have online captions, then you have this option to just translate it, right? So if an Arabic speaker wants to see Obama's weekly address, which always has subtitles, he can just go there and get the subtitles on the fly translated. So, and there are many other integrations on which have been built, on which we are also working. So Gmail, for example, if you get an email in a different language, then obviously you could go and paste it in, but it's much nicer if it's directly integrated. Or a recent one also, which is actually quite exciting, is the toolbar integration, which allows then a very seamless surfing in different languages. So if you then just go to a page, then it will translate it immediately. So you can basically make the whole web in your language. And it really changes the way then you can. Currently, if a link which has a Chinese title on top, you would never click on it because you might not understand. Or obviously, if you're a Chinese speaker, it might be different. But if you don't, then you wouldn't click on it. But with that removes that barrier, you will be able to understand what's behind that. Google Translator Toolkit, so that's for integration with human translation. And YouTube, there's also cross-lingual search. We have a chat integration, Google Reader, SMS translation. And the idea would be machine translation should be just there wherever you need it. So we have it right now that you have it in Google Translate, but there are a lot of very interesting integrations which make then it much easier to get access or to talk to people, communicate to people if it's right there in that application. Okay, so what about the future? What are the challenges and opportunities that are there in the field? So here I go through some really technical things which are challenging for us in order to produce better translation quality. So one of the things is that our models are currently, and the models that are used in the research community are currently very good in figuring out local dependencies. If something is local, and depends on each other, then n-gram models capture that pretty well, astonishingly well, actually. But if things are long distance dependent on each other, then there is a challenge. So here's a mistranslation of a German sentence translated into English. And so here's a German Health Minister, Ulla Schmidt, and then later there is the word "its," which should refer to the health minister, but it's a she. So it should not refer to as its to it. Or then the German has this annoying way of putting verbs that some part of the verb is in the beginning of the sentence and the other part is at the very end of the sentence. And in English, that's just done differently. And therefore, then the translation here of has and was rejected, basically then there should be said it has rejected, that she has rejected, that those allegations are just not at the right place. So in general, everything which is long distance and where there are long distance dependencies is quite hard to get. And the problem is that it's just, there's a very weak signal there. There are a lot of possible long distance interesting relationships if you just look at it from a co-occurrence point of view, but which of those are the relevant ones, right? So this has and this was rejected. Those are the interesting dependency, and the same with the its and the just the entity in the beginning of the sentence. And there are a lot of work is there, syntax-based translation models, two-pass translation model that you first reorder the German sentence, make it more English-like. So you make, out of German, you produce German prime, which then looks like English, and then you translate it locally. And in the field, there's this big debate about how much supervision do we need, how much tree banks do we need, so how much annotation do humans have to give there, or how much we really can learn purely from data. And if we have large amounts of data, some of those things which so far we weren't able to learn, hopefully can be learned. So it's this conflict between linguistics or only statistics. Another one is just a wider context which goes in beyond a single sentence. So the current approach that we are, if you go to Google Translate and you translate something, every segment is translated more or less independently. So a document comes in and gets split up into many small documents, and that makes it then possible that we can very quickly return to you the translation of a web page, because it all happens then parallelized. But then obviously there are a lot of dependencies which as a result are not really captured well. And a few years ago, machine translation quality was not so good that at that time, it probably was not worthwhile to work on that. It was not the next low-hanging fruit. But now for the really good languages like Portuguese or Italian or French, those kinds of issues really are those problems which are still remaining. And So therefore, things like anaphora resolution, so that you know this word relates to that word before, and then as a result, you have to translate it in a certain form, or just topic adaptation, or non-local word sense disambiguation. If you don't know what the meaning of this word is locally, you have to figure it out based on larger context. But relatively little work has been done there. One challenge is that the metric that we are using there is not very sensitive to those very subtle changes, which are subjectively very important, right? If you refer to the person in a different form or you use the wrong sense of a word, afterwards the text just might not be understandable, but this automatic metrics, which measure similarity to human translation, would not be significantly affected. So there is a lot of work also to be done in improving the evaluation metrics that we use. Morphology is another big challenge. I mentioned that before with Finnish. So source language morphology is actually not the biggest problem there. If you have very large amounts of data, for Arabic, for example, we have very large amounts of data. Arabic has a very rich morphology, is rather complex. But once you have large amounts of data, it's actually helping more than hurting, because it's just very precise. If you have an Arabic word there, you know quite precisely what the English translation would be. If you have a Chinese word, you don't know that, because you don't know if it's singular, plural, or many other things. But the much harder problem is then the target language morphology. If you go from a language like English into Arabic or into Finnish, then English, a lot of things are just not specified. You just know them from context. But if you produce an Arabic translation or a Finnish translation, you have to be very specific about everything. So you have to understand really in detail what this is about in order to produce the right translation. And here again, a lot of the research actually goes into English only, but for us, the other direction is more interesting. And therefore, we are seeing the problem probably more than others. Another one is this reliability or confidence measures issue. So some translation mistakes are worse than others. So if you have a mistaken translation where just a preposition is wrong, you forget an article, then that's one thing. But so these are 3 mistakes that we actually did at some point in our system, where a hotel goes to Montreal, where I have no idea. Heath Ledger going to Tom Cruise. That happened also to a time where it was very inappropriate that this would come up. But the interesting thing is, you can then look where you learned that from, right? And sometimes it's just a mistake that those statistical learning algorithms, they paired something which is not correct. But sometimes it can really be a right translation, because translation, what you expect normally from a machine translation is a very literal translation. But human translators sometimes do very interesting and fancy reformulations. So in this specific case, the text that produced that translation was a very good translation produced by a human translator, which did exactly right. But it's just that Heath Ledger is just the most famous, or was there the most famous actor in Australia. And then Tom Cruise, that was for Spanish. I think it was then the corresponding actor in Argentina. Who would that be? Well, and then you choose a different actor, because just Heath Ledger wasn't so much known there. And there the choice was Tom Cruise. And in that context, it was a perfect translation. It was not really referring to that person, but it was referring to the concept of what's the most prominent actor in that country. And so there are very interesting, subtle challenges in how we would figure something like that out, that we don't learn this kind of mistranslations. Or the other one was also a very weird one, where there's some story behind. You can ask me later at the cocktail hour how we could have translated psychosis into Bushback's Blair. So the challenges are there really to filter bad and non-literal training examples, and or that we could at least give users some kind of indication of that that we are not so sure now about this translation, right? So currently we always produce a translation, and sometimes we would have some indication that's the best translation we can produce, but we are not entirely sure about it. Then another interesting topic, I guess probably some machine learning researchers here. So the way then in the end in machine translation, we are combining all those different knowledge sources in this linear model and doing the weight optimization is actually very different than, I guess, in almost any other field, because we are using what is called here minimum error rate training. Every statistical machine translation research group is now using minimum error rate training in order to tune their system weights. So there's this linear model And the training objective is directly to optimize this blue metric. And when I say directly, there's no, it's really directly exactly that blue metric. As a result, the objective function, if you look at it, is a piecewise monotone function. So that's for along one of those feature functions, a piecewise monotone function, which is very wiggly. But interestingly, then you can compute the global optimum of that problem if you basically put in compute that over a lattice of, for one dimension, you can really find exactly that point, which is the peak point for that. And here is a zoomed in version for that. So really the error surface is rather complex. But the challenge is that this just scales to a small number of features. So we can train tens of features with that. But a lot of problems in machine learning, then you get obviously much better if you can train millions of features with that. But so far, that doesn't seem to work yet too well. So everyone is using that kind of technique. Can we scale that up to really large numbers of features in machine translation? Another interesting one is user feedback interactive machine translation. So currently we have some feedback mechanisms in Google Translate. So if someone sees a bad translation, recognizes it's bad, he can tell us this is a correction, and then we might use that in a future version of the system. Or there's a Google Translator toolkit, so that's the integration with a human translator framework, where then if you want to translate a text, you can use Google Translate as a first version, and you just correct the mistakes. If a sentence is translated correctly, don't have to do anything, just go to the next sentence, or then you fix up some of the mistakes. And then obviously we have feedback by just monitoring our discussion group or bug reports, or people blog about it. But I think there is a lot more possibilities there to do interesting things in user interfaces and to just do more interactive machine translation, that the translation is more a dialogue between the system and the user. And especially given that machine translation is still making mistakes and will continue to make mistakes for the foreseeable future, in order for a user then to really figure out if he doesn't understand something, there would be interesting ways to interact with the system. And I think an interesting question really is, can user feedback data for something like machine translation really compare in value and significance to what we get as normal parallel training that we find on the web? It's all data driven. So we find the text as it is on the web, and that's the ground truth on which we operate. Or I'm not sure if I understood.
So you're not using that. So for example, the German verb rules where they split apart the parts of the verb. If you've had some grammar model,
Right. So
correct those kinds of errors, right?
yes. So, and that's actually what we are looking into right now with respect to, so here the long distance dependency, what we're looking into to use then their grammars in order to analyze a sentence and to reorder it and make it similar to the English sentence. But that's ongoing research. So the system that produces this translation here is just pure data driven, and then you get this thing out. And ideally what we would want is that we learn that from data, right? That we don't have the system to tell that, because there's so many special rules and exceptions here that in German it's this, and some other language something else, and you might not find a parser for those other languages and so on. So ideally, and in some sense it's in the data, because as children they all learn that very easily. A 3-year-old German knows where to put the verb, and so the computer should be able to figure that out too. But in the meantime, we are looking into things like that to just explicitly put that knowledge into the system.
Trying to learn the grammar is a different problem than trying to learn the translation. So learning the grammar independently, and then even correct, like you spell
Right.
check before you start translating, like cleaning up, learning the grammar from like some wide corpus, and then applying the grammar to clean the original text up, and then doing kind of the same thing on the other end seems like, and you can do it all data driven.
Right. So there's
the grammar from humans, or you just learn the grammar from lots of texts.
Right. So far the automatic grammar induction work has been I don't know, not very well working or so, but very recently there's there's no, but there's very interesting recent work there where I think really the field is taking off there. And one key thing that I believe will also make that possible is actually parallel text. Because monolingual text alone, I know for a 3-year-old, he has a lot of other information that people are pointing and telling him things, and he makes mistakes, and then he wants to fix them. But for a computer, only the text is it's just very hard, or it turned out to be very hard. But now with parallel text, you have the same text in a different language. So this is everything is basically replicated in a different language. And as a result, you can learn a lot about local dependencies and what's now a different dependency. So if something in English is local together, that's a good indication. And in German, it's so distant. That's a good indication that whatever is distant in German actually also is semantically belonging together. So now people are starting to use parallel corpora and automatic grammar induction all in one, and there are actually more and more paper in that. I think it's a very exciting, interesting research area. Right. 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 No. So we're looking into those things, and it's really that I believe now with those parallel corpora and to basically have this partial supervision from them, and it's not a supervision for the grammar induction, right? We kind of create this supervision artificially because then locality and things like that. So it's not really a supervision saying this is a phrase, but it's a very fuzzy one. That I'm pretty sure will make significant breakthroughs there, and So I personally, I'm of the opinion that all those annotated corpora that we are creating, like Penn Tree Bank, things like that, where large amounts of text have been annotated, that those in the end won't be necessary, that we'll be able to learn much more just from the data itself. We just need to have the right, the right inputs to it. So parallel training data, for example, is one of those inputs which wasn't there before, and also in very large amounts of text, right? If humans annotate 1 million words, that's a large amount of work that has to go into that. But what you have here then is hundreds of millions and billions of words of this semi-supervised annotated text, and trillions of words of just monolingual text, which also has a lot of information in there. So just to my last slide, so I talked about a lot about the challenges and interesting research problems and things we are looking into. But overall, I want to close with basically all these enormous opportunities ahead. So currently, the improvement curve of the machine translation systems is really very steep. Over a few years ago, you couldn't find Hindi English, Thai English machine translation system, and now they are there. They have interesting quality, and just quality is improving significantly. So I think it's not unreasonable to believe that a few years down the road, we'll have the top 40 languages in a quality that's similar to the Italian English quality of our system right now. We'll have many more machine translation languages for which we can do machine translation. I don't think it's impossible that we go from the current 40 to 100 languages in a few years. So 10,000 languages from any of those languages to any other. And really also languages like Yiddish or so, which are minority languages, where it's just a few years ago, it would have been impossible to think about that. And then machine translation everywhere, that it's really integrated into all those places where you need it, that if you want to find out something, that the language is not a barrier, breaking down the language barrier. Thank you. I'm not sure if you have some time for some more questions or... Yeah.
Have you tried translating the Wikipedia? Have you tried translating the Wikipedia, because there are so many different versions of the same subjects? That's an extremely interesting subject, because I have found that different versions, different languages in the Wikipedia are basically made up from different people. So the style or even the information contained in each of them is completely different. So the problem of translating the Wikipedia is very challenging, I think.
Well, so what we're actually providing as part of the Google Translator Toolkit. So the Google Translator Toolkit is if you're a human translator, you can upload a text and it gets machine translated, and then you can post-edit that. So it's an efficiency tool for a human translator. And it's integrated into Wikipedia in this form that you can upload a Wikipedia article, and then there's a machine translation there. You would correct it, and then you can send it back into that language in which you translated it. So that basically makes it possible that then there's, I don't know, the English Wikipedia has probably a few million articles, that those articles which are not existing in some other language, you could then relatively easily and straightforwardly make available there. And basically all in an integrated process where then there's a human translation tool which has all those features like translation memories have, that if a similar sentence has been already translated, that would be in there and things like that. And then machine translation, that if your sentence is already machine translated, well, you wouldn't have to type that again. And making that possible. I'm not sure if that exactly answered your question, but it's basically then, I think there are a lot of opportunities there to make it easier for people to create translated content by using machine translation. A professional translator, they typically don't like machine translation because they just, I don't know, they might be faster without machine translation. But a semi-professional translator, just a normal person producing a translation. So if I produce a translation, for example, it's much easier if I start out with a machine translation and then post-edit it. Yeah. Okay. I'm sorry.
So Google seems to do a great job of gathering information from the things that people are not doing on purpose, like the flu search is telling you where the flu is actually happening. You talked about these parallel corpora that were intentionally created. Is there, and are you looking for sort of parallel texts that are created by, bloggers translating each other's postings and other sort of stuff that could substantially increase the amount of parallel text that you can work with?
Right. So what we try to do, and I know it's ongoing work, is to find all parallel text that's out there. So if there would be a blog post that someone made and someone else translated it, then our goal is to find that. And obviously it's a challenging problem, right? There's so much text out there, and every of those texts you have to use as a query for every other text. But fundamentally, that's what we'd like to achieve, that then all parallel text that is available in those corpora that we can use for that, we would find there. Yeah.
How well does your technique work for translating scientific papers into other languages?
Well, so I guess it's in general, if we have text of a certain nature in the training data, it works better for that as if we wouldn't, right? So if someone asked us to translate United Nations resolutions, it would be pretty good because there's just really large amounts of that type of text in there. So now for scientific papers, it's more challenging, especially also because the topics are so diverse that then in this area and the terminology there is very different from another area. So there are all those very specific domains, and we would have to have training data that covers that vocabulary and that structure. So it depends. And sometimes there are large amounts of abstracts which are available and translated in many different languages. And that's an interesting pool then in order to learn something about that type of language and that style. But I guess, in general, probably the answer would be currently it's not so good, but we are working on finding more parallel data, and then that should become better. Okay, thank you. I think we have to finish.
Thank you very much. Thank you.